let's see how we can actually generate single photons in order to transmit single photons. So we can actually transmit single photons. There are different ways. One of the way would be to have this kind of have a laser source and to put this attenuating plates. If each of those plates would attenuate the laser beam, and after then we would get some single photon output. Well, generation of light by laser would be governed by Poissonian statistics, and this kind of approach is very often used, and it can generate less than 1 photon per pulse. Yes. So the most used actual way to transmit single photons to use laser light attenuation. We can also have different way. We can also generate a single photon source different ways. So for example, we can also use spontaneous parametric down conversion. So the idea is that we have some laser, we have some energy, we have a BBR crystal. And what we do, it's a nonlinear crystal. So when we put energy in this crystal, we actually get a signal. We get a photon. We get 2 entangled photons. So we detect 1 photon, and we would know that detection of 1 photon would herald a presence of another photon. So this way, this kind of single photon generation is very robust, and so the process will be still random, but disadvantages is that sometimes we'd get some kind of false positive. So the detector would detect something when there is something, or on the other hand, he wouldn't detect anything when there should be something. So also we can generate a single photon source in a different way. So we can have some, for example, a system system, for example, an atom, and it can be, let's imagine that's 3-level system. So the idea is that we would like to excite our atom to the short-lived state energy, for example, level 3. Afterwards, atom would decay to a long-lived state E2, and with a high precision would know when the emission of photon would happen from state E2 to the state E1. So indeed, if you ask, those kind of systems exist, and they're called nitrogen vacuum centers in diamond, the systems that can actually generate single photons. So here we have a diamond. It's actually composed of the lattice of carbon atoms, and what you have, you actually knock out one carbon atom and you replace it with nitrogen, and you knock out another atom, and you just leave a vacant place. So I think it's used in other quantum information applications. But once again, the most used way to actually transmit to generate single photons is by using those